Okay, welcome everybody. We are in this is class 4 or 5. And does anybody have any questions before we start? Okay, let's start. Let's see, we were talking last time about observational studies. And there's a difference between observational studies and what are called controlled studies, or treatment and controlled studies. And the idea is that observational studies rely basically on data that you're not really controlling, or you're just collecting it, the data that's already been the thing that you're trying to test about has already been chosen basically by the subjects. So we talked about the example of smoking, and so people have already been chosen to smoke or not smoke, and we have no control over that. Okay, so usually it's like historical data that you're looking at, and you don't really have any control over who does what in the historical data. It just happened already. Okay, and we said that there's a problem with that. And can anybody remind me what the problem is about that?
Correlation does not equal causation.
Correlation doesn't, okay, that's one way to say it. Correlation doesn't mean causation. And can you sort of talk about, say, in this case, the specifics of this case of the smoking data?
Okay, well, we can talk about how there are many drugs that might have radicals that are factors that increase the likelihood of cancer. So we're not exactly sure if, in this case, we're not exactly sure if cigarettes are the cause. So maybe we'll have different control groups to test the accuracy.
Okay, good. Yeah. So he said that there are many other factors that might be affecting the cancer that we're looking at. And we don't really know if maybe the group that smokes a lot, maybe they have a lot of other factors that the non-smoking group doesn't have. And then we don't know which is causing the cancer. So we said maybe, they drink coffee, or they drink a lot of alcohol, or they don't do any exercise. So maybe those things might be causing the cancer, not the smoking. And we don't know. So in the group that smokes, there might be a lot of other things going on that aren't going on in the group that doesn't smoke. So we don't know which thing to attribute the cancer to, right? So that's the problem. So there's one sort of the next natural step in trying to get rid of this issue would be to try and make them, think about all the other confounding variables, we call them. So coffee and alcohol and the not exercise. Think about all of them, and then try and make sure that the data that we analyze, the two groups, the smoking and the non-smoking, also have the same, the two groups, the smoking and the non-smoking, have the same amount of coffee drinking in both groups. And they have the same amount of alcohol in both groups. And they have the same amount of lack of exercise in both groups. So then we won't say, oh, if the smoking group has more cancer, we won't say, oh, it's because of lack of exercise, because they both have the same amount of lack of exercise. They both have the same amount of alcohol. They both have the same amount of coffee. So we can try and identify all the different possible confounding variables that might be causing the cancer, other than the smoking. We could try and do that, and that they do that, but there's a kind of a problem with that. And that you can do without so-called controlling people's behavior. By controlling their behavior, say, you have to smoke and you don't. You can do that without controlling people's behavior. You can just sort of go back into the data, and if you have those variables noted in the data, you can just organize your smoking group only though, have the same, somehow you can figure out some way to have the same same amount of coffee in both the smoking and the non-smoking. So you could kind of do that. And that's called setting up controls. So you're saying, that's saying controlling for other behaviors or other factors. So you could do that. But the problem is that we can't. And if you could do that, then you could avoid all of those other confounding variables. We call them confounding variables. You could avoid all of those, so that would be good. But the problem is you really can't think of all of the confounding variables. I thought of 3: coffee, alcohol, and what was the other one? Exercise, but you can't think of all of them. So I don't know who thought of this idea, but it's pretty good, pretty great idea. And that is, you set up 2 groups, as we saw in the next video. We'll get to it in a minute. You set up 2 groups, and one of them is called the control group, and one of them is called the treatment group. And the control group has the thing that you're kind of trying to study. So if it's medicine, the control group gets the medicine. If it's smoking cigarettes, the control group, sorry, the other way around. I'm sorry, I made a mistake. Doesn't really matter what we call them anyway, but I may as well say it correctly. The treatment group is the group that gets the thing that you're trying to study. So if you're trying to study some new medicine, the people who get that new medicine go into the treatment group. If you're studying cancer, the people, if you could do it, you can't do it, but if you could do it, the people that get that smoke go into this group. You can't do that. You can't tell people to smoke. But anyway, that's called the treatment group, and the other group doesn't get the treatment. And what's the advantage of doing this, or what's the key part of doing this, breaking them into 2 groups? The key part is that you randomly assign. So you get a person and you say, okay, now you go here, next person, you go here. So random who goes where. So what's so ingenious about doing that? What's so ingenious about doing that is that, if you randomly assign people here, you don't really expect that there's going to be a lot more coffee drinking in this group than this group. Basically it should be distributed in the same way, because people are going into both groups. And the same thing with all the other variables, with alcohol, with amount of exercise, everything, but even all the ones you can't think of also, they all should be basically equally distributed into the 2 groups. So somebody thought of that, quite ingenious. That I would say that's really thinking out of the box. I think that's quite good. I don't know how, I don't know if that, I doubt that I would have ever come up with that, even though it sounds kind of simple, but I don't know. Anyway, it's quite good. So they put people into they randomly assign people here and here, so that everything that is, the only difference between this group and this group is not going to be coffee, is not going to be alcohol, it's not going to be exercise, not going to be anything else, except we're consciously giving these people the treatment and these people not. So that will be different. But that's the only thing that will be different about these 2 groups. Then, if something happens to this group, you can say it's because of that one thing that makes these two groups different. So that's the idea of what's called a controlled experiment. So let's, am I sharing my screen? Yes. So let's look at this with that introduction. Oh, I think I forgot to do something. When you share a video, when you share something, you have to say you want to share the sound also. Otherwise, sound doesn't come through. Okay, so let's take a look at this. Who smoke have a lot more cancer than people who don't, but it may be that people who smoke have these other behaviors in common, and so these variables are called confounding variables. Okay, so that is the problem with observational studies. Now, it is possible, even within this observational study framework, to use what are called controls. So we could try to control for these variables, coffee drinking, alcohol consumption, and so on, meaning we could make sure to have equal numbers in both groups. That is, for example, we can have the same number of high coffee consumption in our smoking group and our non-smoking group. We say we are controlling for coffee, or we could do the same thing for alcohol and say we're controlling for alcohol. So what would that do? Then, if we still see a higher incidence of cancer in the smoking group, we can say that it wasn't due to the higher coffee because they both had the same amount of coffee drinking, the smoking group and the non-smoking group. And the same thing we could say with alcohol consumption. We could do the same thing with lack of exercise. But can we really think of every possible confounding variable? You know, we identified a few here, like drinking coffee or alcohol consumption and so on, but it's impossible to think of every possible confounding variable. So no, we can't do that. But there is another approach, and it's called doing a controlled experiment. So no, we can't do that. Okay, so let's see, do we have any tests on this? Okay, so let's go to Manaba and let's have a short individual test right now. It's not going to be a group test. So go to Manaba. And you should see a test called Individual Observational Studies, Observational Studies versus Controlled Experiment Part 1. So go ahead and try and do that right now. Okay, you have 30 seconds. Okay, 10 seconds. Make sure you got it in now. 5 seconds. Okay. Okay, now okay, let's do a group session now. So I will put you into groups right now. So the idea of the groups is, first of all, of course, you're supposed to introduce yourself. And then by introduce yourself, just give your name and where you're from and your APM or APS or something like that. Okay. And then make sure that everybody is clear about the problem. Okay, so let's go to the groups. And I will put on the new test right now. Okay, that was a little bit tricky. I don't know if you realized it was tricky or not, but it said controlling for higher alcohol consumption means making sure that both the high cancer group and the low cancer group patients we include in the study both have high alcohol consumption. And the answer was false for that. It was tricky though. I think the answer was false because it's really not about the groups are not. We don't divide the groups into high and low cancer. That's not how we divide the groups. How do we divide the groups? When we set up two groups, we don't set up high and low cancer groups. If you remember, we have a screen that we looked at earlier, I mean last week, I think, that showed the two groups. What were they? They were treatment and well, anyway, the two groups that we're looking at are smoking and non-smoking. We don't really divide people up in terms of high and low cancer. We divide them up in terms of smoking and no smoking. So that was a little bit tricky.
Professor, I have a question regarding that. How does classifying them into high cancer, low cancer, or smoking and non-smoking affect the question of, because the question is ultimately asking for alcohol consumption. So is it invalid to say that if you want to control for alcohol, that both groups should drink alcohol or none at all? Because the question is mainly for controlling alcohol, isn't it?
Right.
So I think that's...
Wait, sorry? The question is basically what?
The question is mainly asking controlling for alcohol.
Right.
So controlling for higher alcohol consumption means making, so most people would believe that the correct answers are either both the groups, either non-smokers, smokers, high risk, low cancer, whatever the groups may be. Since the question is asking controlling for alcohol, they'll either choose both groups are high alcohol consumption or they don't drink whatsoever in relation to the question.
Right. But are you saying that this should be true?
I'm saying it should be true because the question is asking for controlling for higher alcohol consumption.
Right. But yeah. Okay. I mean, I said it was subtle or tricky because it is about controlling for higher alcohol consumption or controlling for alcohol consumption. So that's right. But it's not, you don't really separate the people into high and low cancer. You separate them into smoking and non-smoking. Okay, so I just want to make that point clear. Okay, so I'm going to leave my answer at that.
Professor, what was the answer to the first question?
The first question, the previous question was the fact that 60% of smokers have lung cancer and only 20 proves that smoking causes cancer. No, that's false.
Yeah, I thought.
Okay, now let's have one more. What's this?
Professor, I actually have a question about the first question as well. So I was led to believe, due to the phrasing of the question, that it's only in regards to an observational study. An observational study meaning like what you can see, right? So if we're talking about, is it accurate? Is it accurate in terms of an experimental study to just make an observation and conclude that, okay, correlation equals causation, then yes, I would agree. But it does state in an observational study. If you're restricted to just an observational study, then I think that's the only conclusion you could make if you're
No.
only constricted to a observational studies. Just
I
like
sort
the
of I
question.
kind of understand what you're saying, but the, you know, I mean, as you already stated to me and earlier today, you can't get, the correlation is not causation. You cannot get causation from an observational study. So it's wrong to use the word causation in an observational study. But the thing is, I mean, oftentimes in the news, you know, you'll hear people mix this up all the time. People who haven't studied statistics well, they'll be talking about an observational study, and they'll use the word causation, and that's completely wrong. Okay. Anyway, I'm going to go on. So we have one more. So where is it? Here. So this one is a well, no, let's go on and watch a little bit more first. Okay, let's go on. But there is another approach, and it's called doing a controlled experiment. So let's talk about what we mean by a controlled experiment. So controlled experiment involves creating two groups and then actively assigning people to one group or the other group randomly. Now, this is not really possible for this particular example of smoking. You'll see why in a minute. So we're going to have one group called the control group, and another group is going to be called the treatment group. And the idea is that we're going to call smoking the treatment. Now, usually this is not, we're not, the example is not smoking. It usually has more to do with, suppose we develop a new medicine and we want to test whether it's effective. Here we're saying that we're developing a new cancer creation behavior, which is smoking. Anyway, but so we're going to call smoking the treatment, and we're going to call people who are not smoking in the control group. So the people who are smoking are in the treatment group, and the people who are not smoking are in the control group. Now, the idea in general, it doesn't work in this case, is to randomly put people in here and here. The reason I say it doesn't work is you can't randomly assign people to this group and say, okay, now you smoke for the next 20 years, and put people in here, and you say you can't smoke. We can't do that. We're prohibited from doing that for other reasons. So we can't do this kind of experiment for smoking. But anyway, this is the idea of a controlled experiment. So the important point, though, is to randomly assign people to this group and to this group. So what's the benefit of doing this? What does the random assignment do? Well, if I randomly assign people to here and here, then there's no reason to believe that people in here are going to drink more coffee than people in here. There's no reason to believe that people are going to drink more alcohol in this group than in this group. There's no reason to believe that they're going to do less exercise in here. And not only that, those are just the three confounding variables that we thought of, but for every other possible confounding variable, we should have approximately the same percentage in here as in here because we did this random assignment. So that's the advantage of doing this random assignment. We basically eliminate all the confounding variables. Then if we find a difference between here and here, we can say that it's not because of any of the confounding variables, because they're evenly distributed here and here. It must be due to the only difference between these two groups is that this group is getting the smoking is smoking and this group isn't, due to the only difference between these two groups is that this group is getting the smoking and this group isn't. So, like we said, this really doesn't make sense for smoking. However, it does make sense for other studies. For example, suppose we want to know if a newly developed medication can reduce symptoms for COVID-19. So what we would do is we would gather a group of people, I guess people who are have COVID-19, and we would randomly assign them to the control group and the treatment group. Now, there's a slight bit of an ethical problem here, you can see, because who gets to go into this group? We have this new medicine, we would think everybody wants to go in here, but we really don't know what is going to happen as a result of this medicine. We're testing it, and it could have negative effects as well as positive effects. So anyway, it seems like there might be an ethical problem, but there's no real solution to that. So we're going to put people in here and people in here. And then if the people in here improve, we can say that it wasn't because of other variables, other confounding variables. It was because of this new medication. Now, there's one other point that they usually make in this kind of discussion, and they say, okay, we're going to give these people the medication and these people are not going to get it. But actually, we give them basically just a pill that has no effect, like maybe it's just a sugar pill or something that has nothing of no active ingredient in it. And the reason for that is that there have been many studies that show that when people think they're getting medicine, they actually improve. And for example, there have been studies that show that when people are in a hospital and they're told they're being given pain medication, even though actually they're not what they're given has nothing to do with pain, they report that the 30% of them report that their pain symptoms have gone down or subsided. So we want to avoid that. We don't want people to get better because they think they're getting the medicine even though they're not getting anything, because that doesn't tell us about the true effect of the medicine. So that is called the placebo effect when that happens, when people report that they're feeling less pain even though they didn't receive any real treatment. So we give what's called a placebo to the control group. So for example, like I said, we'll give them a sugar pill. So the sugar pill is called the placebo. So suppose we have 250 patients, we divide them into two groups, the control group and the treatment group, and we give one group the new medication, that's called the treatment group, and we give the second group the sugar pills. The sugar pills are called the placebo. And the point of this, again, is that we have eliminated all the confounding variables by doing this. And so if there is an improvement in the treatment group, we can ascribe it to the effects of the treatment, of the new treatment, the new medication. Okay, so going back to the observational study, in an observational study, we're not doing this kind of random assignment. And so we're never really sure about whether there's a causal relationship. So we might say that when smoking increases, that cancer also increases, but we can't say that the smoking is necessarily causing the cancer. It could be things that also increase with smoking. And so in an observational study, we're kind of stuck with that. Whereas if we can do a controlled experiment, now as we said, we can't do that with smoking, but if we can, then we're able to talk about one thing, this new treatment causing the effect. Okay, that's all. Okay, we're just going to rush. Okay, are there any questions about this? Okay, let's have another quiz. This is an individual quiz. So you can go and do it now. Okay, 20 seconds. Okay, 5 seconds. Okay. Okay, and let's have one more group session about this. So I'll open the rooms. No cursing about the professor. Okay, does anybody have any questions about that question? Okay, what was the answer to that, by the way? The answer to that was yes, the answer is true, right?
Yep.
Professor Wilson,
Yeah.
So both of them, the answers are true.
Sorry, what did you say?
The answer is true for both of them,
For both of them? The last one was true.
and the one previous.
The one previous?
I believe that one was false.
Let's see. Previous one was controlling for higher alcohol consumption. Means making sure that both the high smoking group and the low smoking group patients we include in the study both have. Why do you say it was false?
It's supposed to be true.
I lost you. I lost your sound.
Sorry, you asked why I answered false?
Yeah.
Okay, sorry, could you repeat that question one more time, sir, so I can jog my memory?
Okay, let me show you on the screen, maybe. Well, I can't do that. It says, I'll put it in the chat. Let me put it in the chat. I
Okay.
can't really show it on my screen very easily. So I will do that in the chat, and I'll send it to everybody. Okay, there it is.
This is the most recent question, correct?
I think
No.
no, the one before.
This is the one. Okay. Hold on, let me check if this is how similar these are.
Mhm.
Hi.
But you can just answer this one just by looking at it. I mean, you should be able to answer.
This one I answered true.
Oh, true. Yeah, wait, let me think. Controlling for higher alcohol consumption means making sure that both the high smoking group and the low. Yeah, it's true. Did I say it was false?
Yeah.
Yeah,
I think it's
there was that confusion. But for this question, it would be true because the most important part is that it's consistent where they either drink no alcohol or they both have high alcohol consumption.
Right. So it's true. Right.
Yep.
Okay. Now, was this the one before, or was that let's see.
I actually believe this question that you posted in the chat is the most recent one.
Going for higher.
No,
It's the previous one.
Yeah, it's the previous one. Okay. Okay. Let's keep going. It's the previous one.
Okay.
Okay. Let's keep going. So one more here. Actually, I have three more, but I'm not going to spend so much time on it. So I'm just going to give you one more. So it's not a group, it's an individual question. So I will open it now. So it should be there now. Okay, I'm going to shut it in 15 seconds. Okay, I'm going to shut it. Okay, so what about that one? In a controlled experiment, both the control group,
I think it's false.
right, it's
False.
Right, okay, good. Okay, so it was false. Hope everybody agrees. Okay, let's continue with the next section. Rush through these following sections.
Professor,
So descriptive statistics is basically usually we divide. Yeah. Yes, sir. Somebody asked a question.
Professor, I'm not sure about like the quiz question. Can you explain for me like why is false?
Okay, so I'll put the question in the chat box, or maybe I'll do it this way. Actually, I can do it this way. Okay, let's do this. Okay, can you see this question?
Yes, I can.
Okay. In a control experiment, both the control group and the treatment group should have approximately the same number of individuals that smoke a lot. So that's not the idea of control and treatment. When we're testing for smoking, we don't want the number of people that smoke to be the same in both groups. We only want to have smokers in one group and no smokers in the other group. It's the opposite.
Thank you so much.
Okay. All right, let's go to here. So descriptive statistics is basically usually we divide statistics up into two parts. So the first half of a class would be descriptive statistics, and then we do something called statistical inference. So that's where we use things like regression. We are actually going to get to regression, and then people do things like big data and data science and machine learning. That's kind of an offshoot of statistical inference. So descriptive statistics is when we just kind of take a set of data and try and describe it. So we talk about what's the mean of a variable, or what's some other measures or just summarizations of variables that we will see. And then, as I said, the second half of a course would be statistical inference. We actually won't have time to go that far, but you'll have the tools to follow up on it if you need to. In this section called Analytics, this is maybe a course that we have called Data Science or Data Mining, and then we also have some courses that follow up on that. So that's when we do things like what we would call analytics, descriptive analytics, predictive analytics, and so on. Okay, we don't need to talk about this right now. Okay, we will be using Excel, and we will also be using a programming language called R. So we'll get to play around with both of those. Okay, let's very quickly talk about ethical guidelines in statistical practice. So they talk about an example here. Here they say, let us consider an example. In section 1.5, we discussed a statistical study conducted by Rogers Institute involving a sample of 200 lithium batteries manufactured with a new solid-state technology. The average battery life for the sample was this. So this is how long these batteries last. and this provides an estimate of the average lifetime for all the batteries. So we had a sample of 200, and their average was this 18.84 hours. And so we might guess that that's approximately what the average lifetime for all the batteries that this company produces is. They say it's reasonable to assume that another sample would have provided, on the other hand, would have provided a slightly different battery average, but because of course each sample will give a slightly different version of the average. So now they give a kind of scenario where a kind of unethical set of practices that Rogers might follow. So they say, suppose Rogers management had hoped the sample results would enable them to claim that the average time until recharge for new batteries was 20 hours or more. Suppose further that Rogers management decides to continue the study by, so they're going to, well, continue the study by manufacturing and testing repeated samples of 200 batteries with the new solid-state technology until a sample of 20 hours or more is obtained. So what they're saying is, first time they took an average, they got this, but of course if they take another sample, they're going to get a different average, and then they could keep checking samples until they got a sample whose average was 20 hours, and then they could say, okay, so our technology produces batteries which last on average 20 hours. Is that fair? Of course, that's not fair. They say if the study is repeated enough times, a sample may eventually be obtained by chance alone that would provide the desired result and enable Rogers to make such a claim. In this case, consumers would be misled into thinking the new product is better than it actually is. Clearly, this type of behavior is unethical and represents a gross misuse of statistics in practice. So there are many ways that you can imagine or that you can figure out to sort of mislead people with statistics, but of course, hopefully, we don't go down that route. Okay, now we're going to do chapter 2. So we can see chapter 2.1. Okay, let's see. First of all, somebody made a good point. So I think they're right. And they said in the last question, there's no mention that the experiment is about smoker and non-smoker. So I think I forgot to say that. I realized it when I was reading it. That they said that is if the experiment is about the treatment for smokers' health problems, it also makes sense. So anyway, so I could see where there could be a misunderstanding about that. So I will adjust marks accordingly because of that on that last question. Okay, we also have another quiz, a quiz about Khan Academy, basically, and homework. So let's go to that right now. Let's see, how many questions are there here? There's, I think, 4 questions. So let's take care of that right now. So where's that? Here. Okay, so I'll turn that on. Obviously, this is an individual quiz. By the way, do you prefer that I send a reminder to your mailbox for every quiz, or I shouldn't do that? I don't know if I'm just filling up your mailbox with garbage. Maybe I'll stop doing that. I think it's not necessary. Okay, there's a quiz there with 4 questions.
Professor, I
Yeah.
can't see the test. Where can I find it?
You can't see what?
The test.
Oh, I think it's should be at the very bottom of the list of all the.
Can you
Well,
share the screen to show it?
I
Can you share your screen to show it? Because I also couldn't find it.
okay. Well, I'm not sure if my screen is going to look like yours.
It's on Manaba.
It's on Manaba, right? You don't see it on Manaba?
Oh, I thought you were talking about Khan Academy.
Oh, no, I'm sorry. The test is on Manaba.
Excuse me, for the question
Yeah.
for 2, it doesn't state what I need to calculate. So there's a list of scores,
Yeah.
but I don't know. There's no question about what to find.
Are you talking about question 1.2?
No, for question 2. Question 2, like asking for a golf team 6 members.
Yeah.
We have to calculate the mean.
Okay. Let me read it. A golf team 6 members had the scores below in their most recent tournament. Oh, the question is just below it. So you have the list of answers, and then the question is just what is the correct interpretation of the mean score?
Okay.
Okay.
Yep. Thank you.
You're welcome. Can somebody's microphone is off. On. Can you turn it off?
What?
Can everybody hear what I just said?
No, Professor.
No.
Oh, I'm sorry. Okay, there's a little bit of a problem on this test. I apologize. The question number 3 is what is the mean? Right? Does everyone understand that?
Yeah.
So your choices are 75, 79, 81, and 90, right?
Okay. Yeah.
And then the next question, question number 4 is what is a correct interpretation of the mean score?
Okay.
Okay, so sorry about that confusion. Okay, so the question 3 is what is the mean? And question 4 is what does the mean mean? What's the meaning of mean?
Okay.
Hi friends, it is today the expect will be, and then we will have to come up with certain treatment so that we can really effect these like switch. And let's go to the experiment. Let's say any experimental unit, the effect of these drugs or side effect of these drugs on the people. So alone is, and for example.
Okay. Okay, let's close this one.
Professor, how many more quizzes do we have to take today?
1,000.
But here in this
That's
case,
a fair number.
drug is applied to these.
Okay, whoever is using their mic, you keep turning it low.
Can you shut the mic, please?
Yeah, please make sure your mic is off when you're talking, unless you're talking to me or the class. Okay, so no, not 1,000, but a few more. Okay, let me turn this one off. Okay, let's just check the answers here. So,
Professor,
yes,
Professor, I haven't submit the test.
okay,
Sorry.
okay. Okay, you can submit it.
Yes. Statistics. Oh, I have to do it. Okay.
Okay, let's go
Okay,
over
thank
this.
you.
Okay, let's go over this together. Okay, so the question says, identify the experimental units. So, and the variable is the gender of students. So what are the experimental units in this experiment?
Student.
Students.
Students, that's right. Okay, good. And then the number of errors on a midterm exam. So the variable is how many errors there were on a midterm exam. So what are the experimental units?
Exam.
Exam.
Yeah, I think the exam is the best answer there. Okay, and then the next one, a bit of confusion, but what is the mean here?
81.
81.
81, okay. Actually, I didn't calculate it, but I assume that you're all right. I mean, I didn't calculate it right now. Okay, and now the next one is, does everyone know how to calculate this in Excel?
Yes.
Yes.
Anybody not know how to do that in Excel?
Yeah, I don't know how to calculate it in
Okay.
I don't know how.
Okay, so let's open up Excel. So I have to share that screen with you. And let's share that screen. Okay. And in Excel, you take the data, you would paste it in there, but unfortunately, it's all like this. I want to have it separated into different cells. Does anybody know how I can conveniently separate this into separate cells? Because of course I can just type it. I could type 70, and then the next cell I could type 72, but I want to do it in a more interesting way than this. Anybody know a more interesting way? Okay, I'll show you a more interesting way. Right now, all of the data is in one cell. Do you agree with that? Watch, when I click on this G1 cell here, you can see that everything is in there. Does everyone understand that?
Yes.
But I want to spread it out into individual cells. So one trick you can use is you go up to the data here. Okay, you go to the data ribbon here, and there's an entry in here called text to columns. Can you see where that is? Text to columns?
Yes.
Yes.
It's
Yes, I
over
do.
here, right? It's over here, right? So what it allows you to do is take a text, something that has text in it, and split it so that it appears in multiple columns, which is exactly what I want. I want this to spread out. So let's try that, text to columns. You have to be selecting the text at the time. So there. So now you get a choice. Is it delimited by something? So is there something that separates the individual numbers? Is there something that separates them or not?
Comma.
Yeah, there's a
Yes.
comma. There's a comma that separates them. So we can use that to split it up. So you just click on next and you say it's not a tab that separates them, it's a comma. And so it kind of gives you a preview of what it's going to do here, which is exactly what we want. You click next again and just finish. And now we have them all so in separate. So you can either leave it like that and click here and go to, you have to go back to the home and go to auto sum and you choose average and it will guess the numbers that you want to average. You just do it that way. Or you can do something else. You can go back to the data, copy it, and paste it vertically, which is here. Paste it like that. And then, of course, you just do the same thing. Click here and auto sum. Okay, and you get the same. Whoops, what did I do wrong? How did that happen? Where did that 114 come from? Was that right?
Yeah, that's correct.
I think you added all the numbers.
Yeah, that's correct.
Oh, I'm sorry, I added all the numbers, right. Thank you. I want this one, average, yeah. Thank you. So you get that. Okay, is everyone clear about that? Now, I guess it's time, in this class, I think I showed you a little bit about using the programming language R, didn't I?
No, you didn't.
Okay, I think I might have in the pre-classes, but let's do that now, just a quick break. So I want you to learn a little bit about R. R is a very good language for data science and artificial intelligence and what's called machine learning. There are two competing languages right now that are kind of considered the best. One is R and one is Python. So anyway, I want you to learn a little bit of R. R is actually built for statistics. So that's appropriate for our class. So let's do that now. So let me stop sharing that screen and let me share my whole screen. Go to here. Okay, so let's everybody try and follow, do these things together. So we want to, in order to use R, you have to install it. It's free, but you have to install it on your computer. And there are versions for Mac and Windows and Linux. So we need to find them first. So you have to type in R programming into Google or whatever search engine you're using, like that. So do that. And unfortunately, it doesn't show up first. It used to show up first, but it doesn't now. Some reason it doesn't show up first. So I have to scroll down to something called rproject.org. You have to find that. rproject.org. Maybe if I type R programming download, that it will come up first. Let's see. Yeah. And then it comes up first. So either this one, cran.rproject.org, or just, I guess this is also www.rproject.org, either one. So I'll use this one. Usually I use this one, but I'll use this one. So rproject.org. and it looks like this. Okay, and now we need to find where we can download. We have to search here. It says to download R, click here. So let's click download R. And that's a pain in the neck. Do I have to do it that way? I guess you do. No, there's a better way than this. Let's try something else. Let's go back to Google, and let's try the CRAN. Download this one. So I've gone back to Google, and this one is better, I guess. cranrproject.org. Doesn't matter. You could have just chosen some place to do it. So up here, it says download R 4.0.0 for Windows. Or if it's not for Windows, you have to find something else. How many people are using, I guess some of you are using non-Windows, so what do we do? So, okay, if you're using non-Windows, I would type in here Mac, R programming download Mac. And then go to here, download R for Mac OS X. So if I go there, I guess you get this stuff. And which one do you have to do? Latest release. I guess it's this one. R-4.0.0 PKG. Okay, so I think I forget how to use Mac. I started using it again recently, but I don't remember exactly that. So I'm sure you know how to do it for Mac users. So I'll go back to Windows here and then download R 4.0 for Windows here. Just click it. And it's downloading. And then when it's downloaded, you can open it. So I'll open it. And I usually, when I install it with run as administrator, but that's up to you. You don't have to do that. So I'm going to do it that way, but over here. So you don't have to do it that way, but I'm going to run as administrator. I think I've already installed it actually in my computer. So, and then you click yes. And whatever language you want. And keep hitting next. And then just finish it. So I'm not going to reinstall it because I already have it. So you just finish it. And then once it's installed, did everybody get it installed already?
Yeah, Professor, there are two options, like if we install, should we install it, customize it, startup, or accept?
No, just do it the normal way. Just nothing customized, just
Okay.
easy
Thank
steps. Okay, everybody get it? Okay, now let's run it. So I'll go here and I'll type in R. Well, yeah. And I see something called R here. So I hope that's the right one. Yeah, it is. Okay, so then you get this kind of awful, it looks like something from the 1960s, programming from the 1960s. But does everybody get this? Everyone get something like this? What? Yes or no?
Not yet.
Not
I'm
yet.
still downloading.
Yeah,
So
it's still
Oh,
downloading.
you're still down. Okay. All right, well, just pay attention to what I'm doing while you're, well, okay, we'll wait. Why not? We don't have anything else to do. Well, while you're waiting for that, let's go to one more thing to download. So in Google, do a search for RStudio, like that. RStudio, one word. RStudio. Do a search for that, RStudio. And then download RStudio, but they have many versions. Only one of them is free. So download RStudio. We want the free one. So just while we're doing the other stuff, let's also do this. Download RStudio. So just click download. And then you can choose your version, Windows, Mac, and so on, and just download it. Okay, so as that's downloading, has everyone gotten R opened up yet?
Yes.
Anybody not? Okay, so let's look at it. It looks horrible, but at least you can do simple things like find the mean of numbers. So let's just practice. Let's do some simple addition. Let's try typing in 5 plus 8, just like that. 5 plus 8. And then hit enter. Doesn't work. Why is that? Huh. Weird. That never happened before. Did that happen to anybody else?
Now mine is working fine.
How it work for me, sir?
Yeah, why doesn't it work? What happened? Let's try it. 8 plus 6. Enter. Something's wrong with my keyboard, I think. 5 plus 9. Enter. Okay, something's wrong with my keyboard. Okay, so do you see that that works?
Yes.
Okay, now if you want to find the mean of 5 and well, I did 5 plus 9, then you could do this. Open bracket, 5 plus 9, close bracket, slash 2, right? That calculates the mean, right?
Yes.
Right? That's obvious, right? Just add them and divide by 2, you get 7, or whatever you got. Okay? But of course we don't want to do it that way. So we can also do this. Mean, open bracket, and then put in some numbers. 5, 6, 7, 8, 9, for example, or any other numbers. And just hit enter. And you get the mean of those numbers. Okay? Everyone understand that?
Mm-hmm.
So you can do that in R. Now I forget, does this work? Median. I'm not sure if this is right. Median. Let's try 3, 4. I don't know if that works.
Professor?
Yeah.
But that's
Is
not
it
a
like
mean.
mean? Is it correct?
What?
No, that's not correct.
Yeah, that's not correct. It's mean.
The mean should be 7.
Oh, you're right. What's going on here? Sorry, I made a mistake. Yeah, thank you. Sorry. Yeah, it's not quite as simple as I said. Okay, what you want to do is, there's 2 ways to do it, but let's do it this way. What we can do is create something to store the numbers in. So you do x equals, we're going to store the 5, 6, 7, 8, 9 in x. So the way you have to do that is you have to do C, means combine, and then put the numbers in. 5, 6, 7, 8, 9, and then close it like that. Okay, so now I'm going to store those numbers in X. So if I hit enter, it just gives me nothing. And then if I want to see what's in X, just type X and then hit enter. So hit X and enter. You can see that I stored those numbers in X. Does everyone see that?
Yeah.
Okay, now you can type mean of X, mean of X, like that, and hit enter. And now it works, right?
Yes, it works.
Okay, good. What is that? I have insert there. Okay, now let's try median. I think median also works. Let's try X. Median of X is also 7, which is true. Okay, let's try sum, S-U-M, of X. And that works also. I don't know why I keep getting that line under there. Insert number line. Insert. Oh well. Okay, so this is you know, obvious, just simple stuff. But let's create another vector. I'm sorry, that X they call it a vector. Okay, it's just a list of items. So let's create another one. Let's call it T. So T equals, and let's have the same number of elements in T as there were in X. So in X I have 5, 6, 7, 8, 9, so that's 5 elements. So I'm going to create another thing like X with different elements in it. Let's say 1, 1, 1, 1, 2, 3, 4. Okay, like that. So I have another, we call it a vector. It has 5 elements in it. Mine has 1, 1, 2, 3, 4. But whatever you put in there, it doesn't matter. Okay, now suppose you want to know, you want to add up X and T individually. So you want to add 5 and 1, and 6 and 1, in my case, and 7 and 2, and 8 and 3, and 9 and 4. Okay, so all you have to do now is write X plus T. Okay, X plus T, and hit enter. And it gives you the sum of those. Okay, does everyone get it? And if you want the multiple element by element multiplication, you can do X, I think, times stars times T, and you get that. Okay, so this is just simple stuff, nothing very interesting, but this is, you can do this in R. Okay, is everyone with me so far?
Yes.
Yes.
Okay,
Yep.
now,
Yep.
but most people don't want to work with this interface. And we downloaded another one called RStudio. So that allows you to be a little bit more, I don't know, just have a nicer way to work with this stuff. So you can close this, and when it says, it doesn't even ask you to save it. And then you can install RStudio. So let's go to that, I guess.
Sorry, Professor. Which one, RStudio Desktop or RStudio Server? Which one?
Only the free one.
They are both free.
Oh, sorry, not the server. Really, they have a server that's free?
Yeah,
Oh,
the server and
yeah,
desktop.
Yeah. Anyway, just the desktop.
Okay.
Okay, actually, I won't go through this right now, but you can install this, and then if you remind me next week, we'll use RStudio, which is more fun to use than R, and we'll do some stuff in RStudio. Okay, so let's go back to the videos now for today, so if you remind me next week, we'll do a little bit of RStudio.
Sir, I have a question.
Yeah.
Is it necessary to use these kinds of programs, or can we just use a calculator to find, like, for finding the numbers and all?
It's not necessary. Well, I want you to learn a little bit of R, and just to become familiar with it, because it's very, very useful.
Okay.
Of course, just for, you know, what we just did just now, it doesn't seem to be very useful. But it is very useful. And I just finished writing a book about R and machine learning, and it was 450 pages. So you can guess that it's useful in various ways. Okay, so but you can, of course, for the simple stuff you don't need it, but it has much more power than a calculator. Okay, so anyway, let's just quickly go back to this, what we have here. I guess I have to stop sharing and then reshare. Okay. And let's go here. Okay, let's look at this. 1, 2.2, 2. And so on. Most of these have to do with summarizing. So we want to summarize data. And we're going to talk about summarizing a categorical variable, then summarizing quantitative variables, and then summarizing two variables together using a table, and then summarizing two variables together using graphical display. So that's what we want to know here. Okay, so let's take a look at that. So we talk about something called a frequency distribution. So here we have some data. What is this? We have a sample of 50 soft drink purchases. So sometimes it's Coke, sometimes it's Diet Coke, sometimes it's Dr. Pepper, and so on. So this is the data. Now this data is clearly not numeric, right? It's a purchase. So we might say the variable is purchase, and the different possible values are not numbers. One possible value for purchase is Coca-Cola. Another possible value for purchase is Diet Coke. Another is Pepsi, and so on. So this is a categorical variable. So how do we summarize this categorical variable, or how can we summarize a categorical variable? So one way to do it is this. So we say how many occurrences of Coca-Cola were there if you count all of them. Turns out there are 19, I guess. How many occurrences of Diet Coke are there if you count all the Diet Cokes? Turns out there are 8. Dr. Pepper, 5, and Sprite, 5. And if you, of course, you sum those all up, you should get the total number of the sample size, the size of the sample, which is 50. So this table here is called a frequency distribution. It tells you the frequency over each of the possible values that the variable can take on. So it can take on the value of Coca-Cola, Diet Coke, Dr. Pepper, Pepsi, and Sprite. And this is the frequency of each of those. So it's called a frequency distribution for this variable, soft drink purchases. Okay, so this is the frequency distribution for the soft drink purchases. So this is the frequency distribution for this categorical variable. So suppose I wanted to know, I asked what percentage of the total purchases is Dr. Pepper. So you can see that there were 5, and the total number of elements in our data set is 50 soft drink purchases. So if there are 5 that were Dr. Pepper, that's 5 out of 50, which is 10%, right? So that would be, we would say that this is 10%. And how about for Sprite? It would also be 10%. And for the other ones, we could figure them out. So in the next section, we talk about doing that. How did we calculate that? We took the 5 and divided it by the 50. Okay, and that's called the relative frequency of the class. So we take the frequency of the class and divide it by the total number of elements in the data set. So here we get those numbers. Here's the 10%, and here's the 10% for this one, and the other ones are given here. And then if you want to talk about the percent frequency, you'd say this is 0.38, so the percentage is 38. This is 0.16, so the percentage is 16. So you could give the percent frequency as well. Okay, so here's the same frequency distribution that we saw originally for this data. So how could we make a picture of this so easily? So we could do this quite easily. We just start out like this. We say Coke, and we said there were 19. We find it, well, we can do the count 19. So we have another axis here. Like that. Maybe 19 is over here somewhere. And then we just have a bar here. Goes as high as 19. And then Diet Coke is 8. So we have some 8 here, something like that, and so on. So this we can do. And so this would be called a bar chart. So we have Coca-Cola at 19 and Diet Coke somewhere else, and Dr. Pepper somewhere else, Pepsi somewhere else, and Sprite somewhere else. And they do a sorted bar chart. So we don't really have to keep this order. This was sort of an arbitrary order. So we could put Coke first, but then we could put Pepsi second, and we could put Diet Coke third, and so on. So we could reorder it like that. We can also do what's called a pie chart, which looks like this. So it says Coke has 38%, and Pepsi has 26%, and so on. And we could do this picture as well. Okay. Okay, that's all we have time for today. So we will continue next week. I will change the homework assignment to reflect what we did today. And yes?
Attendance.
Oh, is Yama-san here? Okay. We'll use the
Hello,
quiz.
Professor.
Yes.
Yeah.
Did you send the attendance for everybody?
I will send right now in the chat room.
Okay. So we'll do the attendance right now as you leave, and I'll adjust the homework for what we did today. So don't go too far ahead. Okay, that's all for today.
Professor,
Yes.
I actually had an issue on Khan Academy because for the assignment, I couldn't be able to.
Yeah, hang on one second. Anybody else? I just want to say you can leave unless you have any question.
Okay.
So if you don't have a question, you can leave. If you want to hear the questions, you can stick around. Yes.
Professor, I will send a response in the chat in 1 minute.
Okay, in 1 minute. Okay. Okay, sorry, go ahead. What was your Khan Academy problem?
So like for some part, I couldn't be able, like even though I put the number on it, but I can't check, like the check button doesn't show up. So I couldn't be able to move on to the next question.
I had the same problems, and I have taken screenshots of it. So I have two screenshots of it. If you'd like me to send as proof, but that has happened as well.
Yeah.
Okay, maybe you can share your screen. That would be good. Let me stop sharing my screen and go to. How do I do this? I have to go to this. Okay. So now you can share your screen with the picture.
I'll just send the image through the chat.
Okay. That's okay too.
Sir, if you're done with the attendance count, may we leave the meeting?
Yeah, you can leave the meeting after you've done attendance.
Thank you.
Thank you, Professor.
Thank you,
Thank
Professor.
you, Professor.
Okay, I don't see the thing you were going to send me. Did you send it yet?
Oh, hold on. I'm saving.
okay.
I'm saving it now.
Okay.
Professor, may I ask you a question?
Yes.
Regarding like the access code to your class, so I still can use the web assigned to do the homework. However, I asked my friends who like who took the class in last year. They said that like the answer must be only limited to 2 or 3 times to like do again. But like for mine, it is like many times I can like correct it as well. So I think that like how say like it is okay for me.
Wait, I misunderstood. You said you, what did you say at first?
Last time, yeah, I just talked with you about my problem about like my access code to website, right? So though I still can log in and do my homework, but like when I make mistake, I can still like how say redo it for many times. But like for my friends of other class, they say that like only the 2 or 3 times to correct.
Should be four times, I think.
Yes, but like I have like many times to correct, so I think it's kind of like free trial.
I see. No, still even with free trial, it shouldn't work like that. But maybe you could share your screen, but let me just look at this first.
Is that picture clear?
Let me look at it. Proof.
Roy, I think you didn't sort the numbers from least to the growing. That's why you didn't get through.
Oh,
you think so? You think that's why?
I like this. We got other answers. We got crowdsourcing for the answer. Let's see. Why can't I find where I downloaded? Let's see. I'll find folder. I can't find it where it goes. Over here.
Should be in the downloads.
Yeah, I would think it's in downloads, but it's not there.
Professor, you can just press open file in the chat box.
Yeah, I did, but mine's not working. Oh, now it is. Okay, now it works. So, what's the issue?
It's the submit answer button. It's grayed out and it will not let me skip questions.
Right. And somebody said they had a solution. What was your solution?
He didn't sort the data like numbers from least to the greatest. That's written in the first part.
That could be why. That could be why.
Yeah, I think that's it.
Because I never thought it would stop me from actually submitting the correct answer.
It does.
Excuse me, Professor.
Yes.
Because I was really confused. I submitted 20, so I calculated 23. I typed 23 there, and then I tried to click submit, and then it says I'm wrong, and I'm wondering what's happening, and so I didn't know you can actually progress that way. And I think for other students that are suffering from this problem, I think it's also because we didn't rearrange the numbers.
Yeah, I think you mean you don't have a submit button there. That's what you're talking about?
Yeah, I didn't know that when I did the homework, but I guess now I know that if you don't rearrange the numbers, they won't let you submit, because you don't really need to rearrange the numbers to find out the answers. I just typed it in my calculator.
Yeah, but for the median, you do have to rearrange them. Well, I mean, obviously you can just put it in the calculator.
Yeah, just type it in my laptop's calculator.
Yeah, but they don't want you to do that. That's not what
it's just so slow to just, drag, click and drag, click and drag.
Of course you don't want to do it all the time. But to get to get practice on the idea of it, you want to move them and put them in order. And then you know, count up to the middle, right? That's the idea, right?
Yeah.
Yeah. Of course, you're not going to
Also-
do this all the time. But,
Yeah.
Yeah. Also, what?
No, I was just about to ask where the respawn data is, but it's just right above the chat, right above the picture. It's all good now. It's all good now.
Okay, great. Very good.
Can I ask a question?
Yes, go ahead.
So my question is about the Cengage. When I entered to my assignments, I saw that there is one past assignment on 26th of May. I think you prolonged it and I didn't done it. So should I do it or do you prolong it?
Let me look. Can you see my screen?
No.
Okay. So let's see, share the screen. So what did you say, Cengage?
We have one assignment that is already passed.
Yeah.
It's like reviewing chapter 1 and 2. So it was on 26th of May. I thought you prolonged it.
Oh. So it was due on the 26th. Which one? Oh, sorry. Which one?
Professor, can you go to the past assignments?
Oh, here, they're all here.
Yeah, chapter 1, section 2 and 3, first one.
No, you're too late. But I mean, you can still do it, but you have to request an extension. So let me just see if I can find that here. So you go to, I have to go to my class, which is here. And then you should see, if you go to,
Yeah, Professor, I saw how to like extension, how to ask an extension. So I think I will get like a minus 12 point scores. I think it's okay. I can do it.
yeah, okay.
Thank you.
Okay.
Professor.
Yes.
Excuse me. This is something of the class. Can I go ahead and just probably brief you?
I'm sorry, I didn't understand.
Yes, I'm saying what I want to ask is of the class. Is it okay for me to do that?
You want to ask about the class?
No, it's off the class.
Oh, not about the class.
Yes, it's not about the class.
Okay, let me stop recording anyway, just a second.
All right.
Let's see, recording. Everybody else, if you want to go, you're welcome to go. Stop.